So this is the last video on the binomial theorem chapter, which is chapter 6. And if I'm honest, you could get away with not even looking at this video if you're just interested in getting the marks on the exam, and hopefully you're not. Hopefully you're interested in knowing where things come from. So what we're looking at is this number, n choose r, which can be written like this, as though the numbers are in a vector, and that number is n factorial over n minus r factorial, and this number, if you remember, is if you have, say, n positions to put things in. Let's say you've got n boxes and you've got r objects, and they're different objects. How many different ways are there of, let's say, well, this is 1, 2, 3, 4, 5, 6. This is 6. Let's say we had 6 choose 2. I could put object number 1 here and object number 2 here. Or I could say object number 1 here and object number 2 here, or object number 1 here and object number 2 there. We could. How many different ways are there of arranging those two objects? If I've got 6 slots to choose from, how can I put those two objects there? And we need to explain why it is this number here, okay? So we need to kind of go around the houses a bit. We need to start with some different problems. So let's start with this idea. If I've got 3 objects, A, B, and C, how many ways are there of arranging 3 objects? Well, I could have A, B, C, I could have A, C, B, and if you see what I've done there is I've got, if there are only 2 objects, B and C, I can have them as BC or CB. Those are my only 2 options. So I've done those 2 options with A in the first place. If I do the same thing and put A in the second place, then I've got BAC or CAB. And if I put A in the third place, then I can have BC there or CB there, okay? So in other words, there are 3 choices for first place. I can have A in the first place, B in the first place, or C in the first place. Once I've chosen the first place, then I've got 2 choices for the second place, so 3 choices for here, 2 choices for there, and then 1 choice for there, okay? So in other words, 3 times 2 times 1, which makes 6 options for rearranging 3 objects. If there were 4 objects, it was A, B, C, D, then D could go in the first place, and then I'd have D followed by all of those arrangements. Or I could put D in the second place, and then I'd get a D everywhere. I'm putting a little line here, so it would be A, D, B, C, A, D, C, B, B, D, A, C. So I could put the D there, or I could put the D in this space, or I could put the D at the end. So there are 4 choices for where to put the D, if you like, and 4 times 3 times 2 times 1, because there's 4 places for the D to go. And then there are, for each place that the D is in, there are all the arrangements of the A, B, and C. Another way of thinking about that is if you've got 4 slots, 1, 2, 3, 4, you've got 4 choices for the first place, 3 choices for the second place, 2 choices for the third place, and 1 choice for the last place. So 4 times 3 times 2 times 1. So what we're really saying here is that this number, n factorial, is the number of arrangements. If you've got n objects, there are n factorial ways of putting those objects in an order. So think about it as if you've got n people and they all want to form a queue, how many different queues are there? So if I've got 5 people, I could have person number 1, then person number 2, then person number 3, then person number 4, then person number 5, and they could join the queue in that order. Or it could be person number 2, then 3, then 5, 1, 4, any old order. There are n factorial different ways of doing that. If there are 5 people, there are 5 factorial different possible queues, okay? And 5 factorial, remember, means 5 times 4 times 3 times 2 times 1. And that number is called the permutation of n objects. The permutations of 5 objects, there are 5 factorial permutations of 5 objects. There are 5 factorial different ways of putting 5 objects in an order, or putting 5 people in a queue, okay? So that's n factorial. The next thing we're going to look at, we've got that bit of information. Now let's think about this thing. If I've got, say I've got a squad of 15 people and I need to choose a team of 3 people, okay? So if I've got a squad of 15 and I need to choose a team of 3, then that is this number here, 15p3. And if you think about it, the first choice, I'd have 15 choices for the first place, and 14 choices for second place, and 13 choices for third place. So it'd be 15 times 14 times 13, okay? If I've got a squad of 12 people, and I need to choose a team of 4. There's a choice of 12 for the first place, 11 for the second place in the team, then 10, then 9 for the other 2 places in the team. So that would be the number 12P4. How many teams can you make if you've got a squad of 12? Now, what's important here, that might sound very similar to 12C4, what we've already described, but the difference is here, if I pick the first person, the second person, third person, fourth person, it doesn't matter what order you get picked. If you get picked first, second, third or fourth of the team, it doesn't matter, you're on the team. Once you pick the 4 people for the team, then those people are on the team, okay? So let's just finish this bit off. First of all, if it's NPR, then that is n times n minus 1 times n minus 2 and so on until I've got r things in a row. Okay, now the way that we write that is n factorial over n minus r factorial. Okay, let's have a think about that. N factorial is n times n minus 1 times n minus 2 and so on. And n minus r factorial is n minus r minus 1, n minus r minus 2 and so on. Okay. Now, if I want r things on the top, well, n minus r here is going to appear somewhere in this string on the top, isn't it? So that will cancel out with one of the brackets on the top. This number is one smaller, so that will cancel out with another thing on the top. And what I'm left with is n minus 1, n minus 2, n minus 3, until n minus r, the last number on the top is going to be 1 bigger than this number here. So n minus r plus 1, okay? And if you count those things, there's n minus 0, n minus 1, n minus 2, n minus 3, and so on. So there are r things there on the top. In other words, if it was 12 choose 4, that'd be 12 times 11 times 10 times 9. There are 4 things in a row. So let's just have an example of that with numbers. If it was 12 choose 4, sorry, 12P4, then that would be 12 factorial over 12 minus 4 factorial. In other words, 12 factorial over 8 factorial. 12 factorial is 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, all times together. So that's what I get on the top of my fraction. On the bottom of the fraction, I get 8, 7, 6, 5, 4, 3, 2, 1. And they're all times together. But this 8 here and this 8 here will cancel out. This 7 and this 7 will cancel out. The 6s, the 5s, the 4s, the 3s, the 2s, the 1s. So all that cancels out. And what I'm left with is 12 times 11 times 10 times 9. So when you see that notation there, n factorial over n minus r factorial, that's a condensed way of writing it. But what that really means is write down n minus 1, write down n minus 2, and keep writing things down until you've got r numbers in a row. And then times them all together, and that is the same as that, okay? All the difficult bits done now, I think. All we have to do is think about this. We've said 12P4 is if you've got 12 people in your squad and you want to pick a team of 4. Now we're looking for 12C4, which is if you've got 12 people in your group and you want to pick 4 of them to join a queue. So in other words, here the order matters. If you're in a queue, it matters if you're first or second or third. If you're in a team, it doesn't matter if you're picked first, second or third. It just matters whether you're in the team or not. Okay, so what we're going to have to ask ourselves is how many, hopefully you can see there are more teams than there are queues, because each team could be arranged into lots of different queues, couldn't it? So all we have to do is work out how many times we've counted each queue. Okay, so 12C4, you've got 12 people to choose from. You're picking 4 of them to join a queue. In other words, it matters who's first, second, third, and fourth. 12P4, you've got a squad of 12 people. You're picking 4 of them to join a team. In other words, it doesn't matter who gets picked first, second, third, or fourth. If you work out how many ways you can arrange each team into a queue, then that is how many times I've counted each queue. So if I divide this number by how many ways there are of how many different ways there are of arranging each team into a queue, then I'll get this number. Okay, and we know that already. If we've got 4 people in the team, then I can arrange them into 4 factorial different queues, can't I? If you imagine you've got A, B, C, and D, those are my people. I can put A, then B, then C, then D, or I could have put A, then B, then D, then C, or A, then C, then D. You know, it's all the different arrangements of that. Those 4 people can be arranged in 4 factorial different ways. So the difference between this number and this number is a factor of 4 factorial, okay? So, in other words, 12C4 would be 12 factorial over 12 minus 4 factorial. Now that so far just means 12 times 10 times 9, 12 times 11 times 10 times 9. And then I divide that by 4 factorial. Okay, so that's the number we're looking for, which gives us the formula that we started with, that we were trying to prove, this formula here, okay? N factorial over n minus r factorial. Remember that bit there just means start with n, write down n minus 1, write down n minus 2, keep going until you've got r things written in a row and times them all together, okay? Divide that all by r factorial, and that is the number you're looking for.